I'm going to be talking about our approach to semantic search and LLM-based question answering on a clinical patient record in FHIR. So my name is Raquel Izquierdo. I'm a product manager at Google Cloud, and I've been at Google for about 2.5 years, and for most of the time, I've been working in healthcare FHIR search. So this is something that I'm obviously very interested in. And what I'm going to do is just introduce a little bit like the work of Google Cloud and FHIR for those that are not that familiar with it. And then I'll get into some of the challenges in clinical search workflows. And then I'll introduce our approach to semantic search and Q&A, and then some real-world examples and implementation. So first of all, for those that are not that familiar with the work that Google Cloud is doing with FHIR, we have the healthcare APIs. So these are a fully managed FHIR server that is sort of like, it's the primary surface for healthcare-specific data management. And so it's a fully managed approach that allows you to comply with the standards and comply with the regulations. And it also it allows you to integrate with the Google Cloud applications and build smart on FHIR applications on top of that. And this also allows you to perform FHIR search, which we'll get into it in a second. But as I was saying, the healthcare API supports data storage and the REST APIs and allows to also perform search on FHIR data. But as we all know, searching for information is a very common workflow in healthcare, but for all the stakeholders really that are in the healthcare industry, so providers, health plans, life sciences, there's a lot of like different questions on the patient record that come up on a daily basis. And so for providers, something just as basic as what diabetes meds is the patient on. And for health plans that are trying to understand, the risk profile of the patient, has the patient chronic kidney disease progressed from stage 2 to 3? And similarly for life sciences, if they're trying to gather real-world evidence, what side effects did the patient experience because of X drug? And so we know that search and really being able to obtain the most value out of the healthcare data is a critical workflow. However, querying healthcare data is hard. And so this is an example that I know most of you are probably familiar with, but FHIR search, if you have a question that sounds as simple as what antibiotics has John Doe taken, you need to know the FHIR API syntax. You need to know the data schema so that you know specifically which resource type, which field you need to search upon. And even if you perform this search, antibiotics is not going to give you a result because that's not really the name of the medication itself. You should be searching for vancomycin or whatever the specific name is. Okay, so even if you try to go to the next level, again, querying healthcare data is really hard. You can try to then compare antibiotics into a few different antibiotics, so vancomycin, blah, 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 like different names, and try to do some level of query expansion. But this is high maintenance, it's highly involved, and you're probably not going to achieve full coverage of all the synonyms and expansions. And even if you're able to do so, you're still going to want to search this in different medication resources. You might even want to search for this in unstructured data. So you can perform these queries. It will return some things, but it might still not be comprehensive. And so we have a lot of customers, that are using the healthcare API, and they're developing their own applications on top of that. But, they were asking us, you're Google, can't you do better than this? We're obviously known for semantic search. What if we were able to provide a more seamless way to query API, query FHIR data, and just allow you to, in natural language, on your own terms, search for the information that you need about this patient? So, going back to the same questions, what if we could just ask what antibiotics has John Doe taken? And so the approach that we took to this is building a medically tuned search that can really allow you to extract the most value out of the FHIR data and really this needle in a haystack use case in which you can find the information there. So the first step is that we build a medically tuned knowledge graph. So this has that underlying clinical knowledge about the relationship between the concepts. So again, going back to the example, we know what drugs are considered antibiotics. So you can expand to these concepts and you can try to do a comprehensive expansion. Then the second step is that we search on FHIR data, both structured and unstructured. So of course, if you're looking for antibiotics, you're going to want to look at the different medication resources. But we're also able to look at clinical notes, but even anything that has been faxed or scanned in, we can perform OCR, and then we can also search over the body of that data. So it's allowing you to first do this query expansion, then search over all the different FHIR resources, structured and unstructured. And then what we do is that we feed that into the LLM in order to get an answer. So what it allows you is to then perform this like natural language question answering, but all grounded in the FHIR data, and sort of being able to provide citations based on that data. So this is overall sort of like the architecture that we have. So starting from the bottom, the sources, FHIR, HL7, any scan docs. And then what we do is that we have a layer of like pre-processing of this data. So we do some harmonization, we index all the data, we do some level of like document prep, so OCR, for example, that I was mentioning earlier. And we also do some enrichments, so some level of document understanding, classification, and so on. And then on the query side, again, you can start with a natural language query. We have some natural language query understanding, and we will also then take the query, and with this clinically tuned knowledge graph, we'll perform the query expansion to all the relevant terms. And now bringing this pre-processed data and the query together, we perform the search. And so we search and retrieve all the FHIR data. So in the context of a specific patient record, we sort of pull up all the FHIR data that is relevant to your question. And using that, we feed that into the LLM to then give you an answer to your question. So for those that were present at the talk earlier that Will was giving, this is sort of that drag approach in which we're allowing to do retrieval-augmented-generation, always rounding it on the FHIR data that was retrieved as a result of the search query. So, okay, this was a lot of talking, so I think it's always helpful to see it actually working. So I'm gonna do a live demo if everything goes well, ideally. But so this is our console for the product, and this is an API product, but we have this like preview just so that it's easier to visualize. So I'm gonna be doing the demo here. The first thing is that you have to select a patient record. So in this case, we're looking at John Doe, synthetic patient, obviously. And what we're going to be able to do is, again, perform a search and natural language querying within specifically this patient record. So this is not sort of like patient cohorts or anything like that. So why don't we just start with a query that we've been looking at? What antibiotics has the patient taken? Okay, so here what we're doing, again, like behind the scenes, is that we're expanding antibiotics to, relevant drugs. And then we are matching all that expanded query against the most common FHIR resources. So I'm sure all of you recognize this, but these are like the most frequently used FHIR resources. So we're matching against all of that, and then we're able to retrieve everything that is relevant. So relevant allergies, relevant observations, labs. For example, there's like a vancomycin blood level. And then the medications. So here is probably, the part that is most interesting for this specific query, but we're able to find vancomycin and, a few other antibiotics that I'm not going to try to pronounce. But we're able to retrieve everything, and then we feed this into the LLM. And so it gives us the answer as well, right? So this is more the, what we're saying, this like question answering component. So it's able to identify which antibiotics the patient has taken in the past. And we do this not only with having all the results underneath so that you can check on that, we actually provide a specific rounding for the sentence. So this specific sentence, from all the search results that we return underneath, this is the evidence where it's getting it from. So I think this is where sort of like this value of like rounding and being able not only to trust the response that you're getting, but also being able to go to the source data and like really validate where that information is coming from. I think another example that I want to show, as I was saying, one of the key value props of this is that we're trying to allow users to search in their own terms. So, for example, a common abbreviation for antibiotics, AVX. Let's try it. But overall, the results are pretty much the same. It's able to expand, it's still able to retrieve the relevant medications, and it's also giving you an answer with, again, the grounding, and so on. I'm going to try another example just so that we not only focus on that, but I'm going to look for diabetes. So in this case, I know that John Doe has diabetes. So I'm not even asking a question directly. I just want to get an overall summary for what is the diabetes state for this patient. So what this is doing, again, is like it's pulling information from all the different FHIR resources, and it's pulling up everything that will be relevant to manage the diabetes of John Doe. So in observations, we have relevant labs that are being pulled up. So A1C, for example, glucose levels, all of this is relevant if you're trying to manage the patient diabetes. We're also able to retrieve metformin, again, relevant medication to treat diabetes. And we're also able to go into compositions and medical notes. So, we're also retrieving here dimensions of diabetes. And even just looking very quickly at this snippet, I can already see, that this patient has diet-controlled diabetes. So I'm already learning about it. And as we mentioned at the beginning, the value of this is also unlocking a lot of the power of an information that is in scan documents and anything that has been faxed in. So looking at this, we're able to also pull up a diabetic food exam that is just a scan form, but obviously it's relevant for diabetes management. And similarly, we also have another scan document. In this case, it's a diabetic retinopathy exam, in which we're seeing some results of for John Doe. So overall, again, it's allowing us to really search all the different FHIR resources in this data and try to extract the most value out of it. In this case, I didn't really ask a question specifically, but it's still giving me, a quick summary, like the patient has a history of diabetes and the most recent A1C. Let's try to ask another question just to validate this again. Is the patient on any diabetes meds? And we've already seen this from the results underneath, so it should be that the patient is taking metformin. But yeah, we can validate this here. And again, it's not just telling you that the patient is taking metformin. You can also validate the grounding within this specific sentence. And you can also go and find the search results underneath. We go to medications, and you can find that the patient is taking metformin. So yeah, I'll continue with the slides. This is the demo for now. But I think the last thing that I wanted to communicate to sort of like wrap up this section is that this is an API first product. So I was showing a UI that is very helpful in order to visualize this more efficiently. But really this is an API input, and then we can also see the output. It's a JSON response. The output is the FHIR resource, and then we also have the LLM summary with the different citations. So just to show how this actually looks like from a developer standpoint. But that sort of concludes what the product is. Now what I wanna share are some of the customer testimonials. So I'm not sure which ones of you were in the Mayo talk this morning, but overall this is the technology that is empowering their clinical record Q&A product and use case that they presented this morning. And so that's sort of the underlying technology, and that is a product that is, it's currently in production, is being used for about 100 to a couple hundred users, and it's getting pretty good feedback. And then we also have a pilot that is currently active at Meditech with MildBluff. And if we look at some of the screenshots, it looks pretty similar to what I just presented. Again, it's taking all these different FHIR resources, organizing, retrieving all of the results, and allowing them to unlock the value from scan documents. And just some of the feedback that we've been getting so far, what this really allows you to do is be more efficient in information finding. The moment you're more efficient, you can do it more quickly, you can do it more accurately. The way I've heard someone say this in the past as well is that it lowers the opportunity cost in order to find information about the clinical record. So it really allows you to do this needle in a haystack and to deep dive and to find all the information in a most efficient way. So it saves time, and it streamlines different workflows that require searching and scanning the patient data. And I think the other component of it that is no less important is that it also increases the confidence. So all doctors want to do their due diligence, and they want to feel like they've done the most in order to get the best quality information that they have so that they can provide the best care possible. So this allows you to better understand the patient's baseline, but also just feel more confident that you have actually done your due diligence, that you have reviewed the patient record in the best possible way that you could, and that you've been able to scan for all the information. So just broadly speaking, what this allows you is to make the next level decisions in which you can save time and you can feel more confident. And that's the goal that we're trying to do with this product. So yeah, Q&A.
Yeah, this is Victor from Singapore. Thanks for your talk. Very inspiring. So I have two questions. First question is, if the technique you use is the same, the one just now, I think we're outside just the Memorial Hall, talk about the the Google technique,
Yeah.
how to using the FHIR data. But what he says that this approach is more suitable for POC. But what you this morning, I think also the talk for Mayo Clinic. In fact, this is already in production. So I'm not sure is it the approach you in this Mayo Clinic is different from what we'll just now share. Then second point is like second question is when you feed the data, the file data into the large language model, do you do any pre-processing? Yeah, thanks. Yeah.
Yeah, so a couple of things. To the first question, I mean, Will is here if you want to cover, but I think what he was trying to do is, we have the pure deterministic way, and we have the way in which you kind of ignore FHIR and just like shove it all into the LLM. That's the one that he was saying there might be potential in the future, but that one is still at the POC. What I'm presenting here was that like middle column, that middle ground, in which you still have FHIR data, you still do search over FHIR, you retrieve the FHIR resources, and then you do retrieval-augmented-generation. So what we're saying is it's a mix in between, in which you're still using search, like the deterministic search as the first step, and then you build the LLM on top of that. But that allows you to have good grounding, that allows you to always refer back to the data that you're inputting in order to provide the response. So if we're trying to go to the very, like just shove it all in there, that is a POC, because I think that it's really hard to ensure that it doesn't have hallucinations, and it's still not production ready. This was like a little bit like getting it out there and testing it. Where we are right now, it's in the middle, which is, being in production, and we're getting good results because, as I was mentioning earlier, it's not just trusting the LLM, but also you always have access to the source data in order to validate it. And I think this is where we are right now in something that can be deployed in production and used by real users. That's sort of like the first question. The second question, we do some level of pre-processing of the FHIR data. I think one of them, even just OCR will be considered like pre-processing, right? And so you have to be able to do the OCR on top of the document, but also we need to dereferencing, like for some of these fields for medications, if you have the author, you have to dereference back to the author. And then we also do some level of essentially our own enrichments and harmonizations on like some document understanding and things like that we have found increases the overall quality of the retrieval of documents and the LLM summary. So we do some level of pre-processing on it just and to ensure that we keep improving the models and that we keep getting better results.
Thanks.
So the RAG that you mentioned in the hybrid model, is that something Google is building on behalf of the clients, whether it is Mayo or somebody else, or is the client building it and providing it to you guys to do the integration?
Do you want to answer? To Damien?
So Mayo is doing both. We are implementing fully custom RAG systems that we're just running on Google Cloud's platform. This system, what are we properly calling it now? Vertex AI Healthcare Search, the name keeps changing slightly, is a service offering from Google. We just point it at the FHIR store and call the API, and it does everything else.
Yeah, I think there's some like level of customization that you can do, like preamble and so on. But overall, I think what we've seen other customers do as well is, depending on what is specifically your use case, you can also build sort of like an query intent parsing on top of that. So if you have something that is more like an agent, you can say, like if you're just asking me a general domain, general knowledge healthcare question, this is not something that you need to call this for. This is something that you can call MedLM or any other LLM of choice in order to answer. So we have some customers that if they're doing this with like a more broad like agent kind of use case, they will have some level of pre-processing, not pre-processing, but like query intent understanding to see whether they want to call this or to redirect where it should go. But overall, yeah, as long as you have FHIR data in our FHIR store, you can connect to this and you can get it up and running in a few hours.
Thanks for the presentation. I was wondering if you could talk a little bit about the implementation details, if there are any challenges, any unique problems that you guys ended up solving.
Yeah, I mean, I think challenges is, overall, as everyone here knows, every FHIR data is a little bit different. And I think at the end of the day, the better quality of the data that you bring, the better quality of the output that you're going to get. At the same time, we're trying to build this as a tool that is as generalizable as possible so that even if your FHIR data isn't perfect, this is still going to allow you to unlock the value out of it. So I think balancing these two of like, what is the expectations of how we can get the data, but we still want to make it as bulletproof as possible. And like, as long as you have the data here, we're going to return something valuable. I think that's one of the key challenges. So at the beginning, for example, we were more prescriptive about which specific FHIR fields we were indexing and which ones we were returning and so on. And now we have it in the pipeline that we're going to come up with another feature that allows each customer to customize specifically, which FHIR field to index and so on. So that allows to a little bit more flexibility of you knowing your underlying FHIR data and how it's structured. You can still like play with this and you can still get good results. So I think that level of, how can you make something generalizable and customizable at the same time, I think is one of the key challenges.
One last question.
So when it comes to multiple FHIR, like you have the FHIR underneath and you have the DICOM, like the imaging and other source types, when you had that search result returned, I didn't see the imaging related study returned. You did have document reference, but it didn't have imaging study. So you are not correlating through, like, is it something, an assumption that when it comes to navigating through multiple stores, be it like FHIR and imaging, you do not have the imaging study being utilized directly, the document references?
Yeah, we do not support multimodal or like DICOM search at this point. So this is just like purely the FHIR data. So yeah, well, you will have, if you have any sort of imaging, you will have the imaging report, and we can get that data. But we're not doing like image analysis. We're not doing multimodal at this point. Yeah.